Lord's Prayer. Our Father, who art in heaven, hallowed be the name. The kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us, and lead us not into temptation, but deliver us from evil. For thine is the kingdom, the power, and the glory, forever and ever. Amen.
ஆனா மேம் வெபினார்ல ஜாயின் பண்ணதுக்காக கால் பண்ணி ஓகே மேம். Once again, I call for this Rahavi, Final Electability Department. Give the intro about the resource person, Dr. Kunavil sir. Rahavi, are you in line?
Yes, ma'am. It's my privilege to introduce our chief guest, resource person today's session, Dr. G. Kumaravel, Senior Lecturer in the Department of Engineering and Technology at the University of Technology and Applied Science. He brings with him a woman. Dr. Kumaravel has an institution academic career spanning 23 years, having served as an assistant professor at Arundel Engineering College for 9 years, associate professor at RMT Engineering College for 5 years, and for past 9 years, senior lecturer at University of Technology and Applied Science. He hold a BE in Electrical and Electronic Engineering and ME in Applied Electronics and PhD in Electrical Engineering. His academic contribution include 45 publications in reputed journals. Dr. Kumaravel has secured a research grant worth approximate 84 lakh surprising and certificate project. Now I hand over the session to Dr. Kumaravel. A warm welcome, you sir.
Thank you, ma'am. Thank you, miss. Good evening to everyone. Is my voice is audible?
Yes, sir, it is audible, but it is voice is very low level.
Okay. What about the PPT? Is it visible?
Yeah, it is visible, sir.
Okay. First of all, I would like to say my thanks to the management for giving this nice opportunity. Myself, Dr. G. Kumaravel, Senior Lecturer, Department of Engineering and Technology, University of Technology and Applied Sciences, Idris, Sultanate of Oman. In this session, just I am going to brief the solar PV forecasting technique, especially for standalone systems, by using artificial neural networks. Vijay ma'am, is my voice is okay?
It is audible, but it is very low level.
One minute, ma'am. What about now? Is it okay?
Now it is okay.
Okay. So this is the presentation topic. As we know that nowadays in almost in all the countries, they are trying to match the power demand or energy demand by using the renewable energy systems, because these renewable energy systems are very neat and clean compared to other non-renewable energy systems. For an example, if you are going for the thermal power plant, you have to burn the coal, and you know that it will pollute the environment, and also it is depleting in nature. So that almost in all the countries, countries, they are focusing on the renewable energy systems. So many renewable energy systems are there. Solar energy systems, wind energy systems, geothermal energy systems, fuel technology. Recently they are focusing on the green hydrogen. So many technologies, so many methods are there. Among all the renewable energy systems, the solar photovoltaic system is considered as a prominent one. Because if you are going for wind energy systems, it depends on the topographical nature of the particular location, or it depends on the terrain. If you are planning to install wind energy conversion system, you have to see the seashore. Or if you are going to install wind energy system for offshore power plant, you have to assess the wind pattern and wind speed in the particular location. So these are all issues in the wind energy conversion systems or wind power plant, or simply we call it as a windmill. Or on the other hand, if you are going for the geothermal energy, it depends on the terrain. If it is a rocky terrain, it is very hard to install the or implement the geothermal energy systems, because the initial investment cost would be more. But if you consider the solar photovoltaic system, these issues would not be there. If you are going for solar photovoltaic system, we need only the sunlight, and even the countries like Denmark, in most of the year, the sunlight is very low in intensity. That means the solar radiation level is very low. Even that we can use solar photovoltaic system, because for solar photovoltaic system the optimal temperature is 25 degrees centigrade. Even at the low light vicinity, the solar photovoltaic systems works very well. Their performance is are very good. The countries like Oman, I think most of you are aware about Oman, Dubai, because these are all the GCC countries. There, the the solar radiation level is very high, because most of the GCC countries are desert in nature. Especially in Oman, most of the area is a terrain. The area is a desert in nature. So these places are witnessing very high solar radiation level. So solar PV system is a best a method to harvest more energy in the mass production level. Vijay ma'am, is my voice is audible now? What about the PPT ma'am? Is it visible?
Yes, sir, it is visible one. The voice is also audible.
Okay ma'am. So now the problem in solar PV system, because now we have seen what all the merits of the solar PV system. Now we are going to see the drawbacks, the demerits of the solar PV system. The only one major drawback or demerit in the solar photovoltaic system is output power intermittency. The output power is not a reliable one. It is not a constant one. It is always varying with respect to the solar radiation level in the plant site. Now the problem in the solar radiation level is, it is depending on the climatic conditions. It depends on the wind speed, temperature, humidity, pressure in the plant site. Even sometimes the air currents, which is wobbling or wavering around the solar PV system surface, also impact the power output. And cloud cover, most importantly cloud cover. So these weather parameters are unpredictable in nature. We cannot predict the temperature in the particular plant site. It can be vary day by day, and we cannot predict the wind speed. We cannot predict the pressure. We cannot predict the humidity. Every year, we can predict. Every year by year, this pattern would be the same, almost the same, but not exactly. So these weather parameters are not same. That means the solar radiation level is not constant in the plant side. This will affect the power output of the solar PV system. The output power also fluctuating in nature. So if I want to connect my solar PV system with the grid, then it will affect the stability of the grid. So this is called solar intermittency. Solar intermittency means the output power of the solar PV system is not constant throughout the period. It is wobbling in nature or fluctuating in nature. So we need to forecast the solar